Well, hello everybody, I'm back, and I actually wanted to, well, my goal here is to hack factoring by grouping. Now, factoring by grouping is an elaborate series of algebraic dance steps that historically causes my students problems. It's a special technique to crack four terms into two binomials multiplied together. And there's a lot of inside-outside moves that just throws my students for a loop. And the way it's taught in all modern algebra books is to use these elaborate dance steps to do the cracking. And I've come across a much superior technique, a hack if you will, that really cuts to the chase and leverages what you've already learned earlier on in algebra without introducing any new dance steps. In fact, it's so superior you're probably going to think it's illegitimate. And so you're probably wondering, well, if it's so good, why doesn't it appear in these modern textbooks? And I'd like to make a supposition for you here. Namely, consider if you were writing a modern textbook, what would you do? Chances are good you would read existing modern textbooks and see how they handled factoring for terms. And you would parrot them. You might bring new problems, new material, your own words, but you'd parrot the technique. And actually, I'm not being hypercritical here. That's good. I mean, you want to stay within the norms. You want to not get too far off the reservation when you write your textbook. And so that's how this idea of factoring by grouping has persisted. Now, what I want to do is actually chase it back historically, just out of curiosity. This is the textbook I had in 1976, though it was published first in 1970. Let me show you how John Minnick, who was actually my teacher, treated the idea of factoring by grouping back in 1970. Here is Minnick's work on the whole thing. Now, notice he doesn't have a chapter or a section devoted to factoring by grouping. It's basically treated as an aside. It's one example in a series of examples on factoring and a section on factoring. Now, here are the four terms. And if you're a math teacher, just as an aside here, you know that Minnick here is actually showing you the easy condition. That is, when the sign between the second and the third terms is a plus, this scheme here of factoring by grouping, which he walks the student through very quickly, very succinctly, is much easier to run. If this is a minus sign here, the error rate among students increases by, say, 20%. So not only is it an aside in Minnick's book, but it is also something that he is not even concerned about. He's not even going to show the more difficult cases. Then, as we go through time, well, 40 years later, here's our textbook here. And you've already reviewed the material. You've seen factoring by grouping. It has its own section. It has 2 pages of text. It's quite elaborate instruction to walk you through all these moves involved with it. I thought, instead of using our textbook, though, I thought it would be sort of interesting to follow it one step further and into college algebra, which is probably your next course. And here we have a look at Paul Cézanne's book. This is 2003. And I thought you might be curious to see how factoring by grouping is taught there. And lo and behold, here is Paul Cézanne's work. Notice here that it's now treated in college algebra as a review item. It's in chapter 1, very early in the text, page 58. He has about a half a page of text, and he has 2 examples, and he shows the easier case and the harder case, and lots of text showing you these elaborate dance moves. And then on to the problem section. And in fact, that's what I'm going to do, is I'm going to go on to Paul Cézanne's problem section, and I'm going to run my hack. Not factoring on by grouping. I'm going to run my hack for factoring by grouping on these college algebra problems from Paul Cézanne's book. Okay, so there are the problems, and let me run the hack and just walk my way through these and see if you don't pick up the technique. So let's work this first one, and what I'm going to do here is go straight to the 2 binomials that I suspect these 4 terms factor into. And I'm just going to generate that first term. Probably it's going to be a squared times a. Now, it's possible it could be a cubed times 1, but as you work your way through these, you begin to choose the right choices, because there's a bit of a pattern. It's very intuitive. So I suspect that this is the proper way to get the a cubed. Please note that a squared times a does in fact give me a cubed. So I've gotten 1/4 of the problem. And now the beauty of the technique of the hack is that you can go for any one of these other terms. And so order really doesn't matter. That's what's so gorgeous about it. Now I'm going to go for the second one because I've got an a squared here, and this one has an a squared in it. And I see if I had a negative b over here, then when I do this multiplication right here, I'm going to get a negative a squared b. And so that gives me my third term, and I'm halfway home. How about I go for this one? I need to get a positive ab, and I see if I put a plus b here, that in fact, this multiplication here gets me plus ab, if you will. And so there's 3 out of the 4 terms. All I need to do is check that there's a multiplication that generates a negative b squared. And you can see that this one indeed gets me my negative b squared. And so that's it. I've cracked it. I've hacked it. And no new technique. Just leveraging what you already know in regards to the multiplication of 2 binomials. You know from your double distribution or from FOIL, however it was taught you, you know that there's going to be 4 multiplications here. And these 4 multiplications are going to generate 4 terms. And it's a perfect symmetry. There are 4 terms over here. I'm just basically running the idea backwards. That's what's so beautiful about it. It doesn't require any new techniques. And so we are essentially superannuating factoring by grouping. It isn't necessary. It doesn't need to be taught the way it's taught. How about we try this problem here? Now notice this is a polynomial expression, and it's written in ascending powers. I can run my hack with it just the way it sits. But for teaching purposes, it's a much simpler problem if we write the polynomial expression in descending order. And that's the way polynomials get written anyway. So this is a nice little a bit of side instruction in that we always write the polynomial in descending powers. And the reason we do that is because this is the big dog and we want to show him up front. He's the one that influences the whole polynomial. So I've rewritten it essentially in descending powers, and now I'm going to go ahead and run the hack. I'm going to go straight to the 2 binomials, and I'm going to get that first term. And again, experience tells me that it's probably going to be z squared times z squared. Notice that gets me the z to the 4th. And so we're on the road. And now we need to get this z cubed. And I see if I put a plus z here, that when I do this multiplication right here, I get z cubed, positive z cubed. And that's the second term. And now we look to generate this one, a plus z squared. And I think if I put a plus 1 here, really that's the only way we're going to get, when we do this multiplication, a plus z squared. And now I just have to check that the final multiplication generates a plus z. Please note that it does. Plus z times plus 1 is a plus z. And there you go. I've hacked that one. No problem, no new technique. Very simple, little to memorize, and it makes you stronger in the other aspects of your algebra, which is the multiplication of binomials. Okay, I'm going to work one more here and then challenge you. How about I try this one? I'm going to go straight to my 2 binomials, and an x times an x will give me an x squared. So I've got the first term. I'll go for this term next, plus 3xy. I see if I put a plus 3 here that I get a plus 3x, but not a plus 3xy. So I need to put a y in there. And please note, that multiplication gets me plus 3xy. So halfway home. And now I need to generate a plus 3y. And I realize that when this multiplies against the plus 1, that I get plus 3y. And that is my third term. And all I need to do is to check that there is a multiplication that generates a plus x. And there it is right there. X times plus 1 gives me my plus x. And so I've done it. I've hacked it and cracked it. And here we are. We've basically zipped through these problems without too much strain. And if you think this technique cuts like a knife through these harder college algebra problems, why do you try it against your intermediate algebra problem set? It positively zips. Now, what I'm going to do is pause for an instant and ask you to run the hack on that problem. And when you come back, after the pause, I will hack that one for you. Okay, I'm assuming you gave it a go. I'm going to hack it. I'm going for my 2 binomials straight away. And I'm going to try 2a times c. Now, it could also be 2c times a. I may get it wrong here. I may have to backtrack and go that other direction. But let's try this. So there's the first term. And now I can generate any of these other 3. How about I go for this one? Because I see if I put a plus b here, that in fact, this multiplication right here is going to give me a plus bc. And so that would generate the third term. And now all I have to do is get one of these other ones. How about a negative 3bd? Here's my b, and I see when I multiply this direction here that if I had a negative 3, I'd have a negative 3b, and if I put a d in there, I'd have a negative 3bd. And that would give me my third term. And now all I have to do is double check to make sure this is good. And I see that when I do this multiplication, I do in fact get a negative 6AD. And so I've cracked it and hacked it. And there you go. So that's the technique. And if there's any possibility of confusion on your part, it's probably because you're too wholly wedded to FOIL, which is a bit of a crutch that math teachers have hindered you with in the past. And even though I think you could still follow me quite well if all you know is FOIL, but really want to get the full Monty of this, really understand what I've done here completely, and understand FOIL completely and double distribution completely, you need to watch this video that I made earlier in the course and give that a go. But I think you're pretty cool with what I've done here, and it works. And so let's say goodbye to factoring by grouping, and let's just hack it when we have 4 terms. No problema. Okay, I hope that helps. Be talking to you again soon.